Hello everyone, I hope you're doing well. My name is Abdallah and I am a software developer. So today I am going to be solving the famous Caesar Ciphers algorithm. So what does it mean? Julius Caesar protected his confidential information by encrypting it using a cipher. Caesar cipher shifts each letter by a number of letters. If the shift takes you past the end of the alphabet, just rotate back to the front of the alphabet. In the case of a rotation by 3x, W, X, Y, and Z would map to Z, A, and B, and C. Okay, very interesting. So the example here is original alphabet rotated by 3. There is a starman waiting in the sky, you get this, and the cipher only encrypts letters. Symbols, such as this one, remains unencrypted, of course. Like we see here, the capital remains capital. Okay, very good. Should get this. So I actually tried solving this problem a few times already. And there are different ways to do that. So you can use, for example, the Unicode table, and you get the decimal values that you can just add 3. I will show you why. But otherwise, you can also use an array. And with the array, you just simply, where is it? Let's go to the easier one, the one on Wikipedia. So for example, you know exactly where capital letter A starts, so you can use this value, 65 to 90. This one are basically symbols, ASCII punctuation and symbols. And then we have these ones as well. So we go until Z, which is 122. So what you need to know, obviously, is 122 removes 26 is 97. So what we need to do is to play a bit with this letter, and then we just you can also keep track of this value, these ones, to always refer, like when you're at Z and you want to get back to A, you just want to refer this. But then if you refer to each of these values individually, you also need to be keeping track of uppercase and lowercase. So let's try something that doesn't do that. So I've tried 4 or 5 times already using different types of algorithm. And it can be tricky, to be honest, but it's not that difficult as well. So the algorithm, let's just start with the algorithm first. So it will give me an error. A very easy algorithm. Well, actually, if you write the algorithm first, it will be a bit easier. So first we need to take the array and move it. So basically we can use a map. Otherwise we can also use an each iteration, but then we need to keep track of we need to have a return result. So map is very easy to, so we need to check if it's a, remember it's a letter or symbols, and that's the biggest if actually. And of course we need to return a string and not an array. It's not an array. So we know at some point we are going to be using join. Check if it's a letter of symbols. Okay, if letter, if not letter, return return a symbol, and otherwise as simple as that. We just need to understand what are we looking for now. Do we check if the value that we are moving is already the n, that is the corner edge, the corner or edge case, it's already, for example, Z, lowercase or uppercase? Do we want to check that, or do we want to add the value first and then check it, and if it's over the either Z, and then we restart at first? So I think we add it first, it's easier. Add the value k, which is the shift value. What's happening? shift value, and then finally under shift value, and if it's over value of z, and if it's that value, we just minus 26, because remember we have taking from A to go to Z, it's 26 letters. So this is the algorithm. Let's start maybe up. And also one thing to know is that to convert between the Unicode basically means that you have a unique code for irrespective of any language, not programming language, but the language, for example, Aramaic, Indian language, or any other language, you have a unique value that always points to the same either decimal value or, let's see, so octal, decimal, glyph, etc. So we use a glyph one, of course, and to do that, we've to convert a value to the decimal, we use O, ERD, and then to reconvert back, we use CHR. Okay, with all of that in mind, let's begin. So we are given a string. With the string, we need to convert it to an array, because in Ruby doesn't iterate over a string like Python or any other language. So s dot split everything by space, and then we just map it to, okay, we give it a block. This is the letter. Yes, very good. Now we need to check if the letter itself is if the letter is letter is Unicode, is letter, so the letter itself is a letter or a symbol. All right, so there are several, in Ruby we have so many ways to do that. I'm just going to copy paste one of them. So this, we are checking if it's in the range of and here it's basically it's no other than our good friend. And let me copy paste it rather, I otherwise can make some mistake. So this is our good friend regex. So why not we are using regex, because it's much simpler. So if we have a letter that is a letter, then what we do, we just need to plus the shift factor. But before we do that, we need to remember that every if should have an else, theoretically speaking. So we just return the letter. And what you want to know with Ruby is that, I mentioned this so many times, but in Ruby the last element is returned. So right now we are using a map. The map will always, so a map is just a way to transform an array, and by writing a map you return the value, you return values. And if it's the last element, actually when you are going through the condition, it will return it. So here we have a letter, we return, this is basically the symbols condition, and now we are going to just return the letter. We need to convert the letter to the decimal. We use the odd method, and then we shift it. We have k, which is also the shift factor. So that's it, we have the letter, we plus it, and then it's good, it should work. Actually we just need to like I said, we need to return a value. Okay, if it's a symbol, it will return the value. If it's a letter, it will plus 3 and return it. Well, it's not going to work actually, because we need to return the we actually need to return the letter, the character, in fact. Okay, that looks good. It's simple to understand. Let me just enjoy a cup of tea. Oh, nice, very nice. Now we need to take into account the corner case, or the boundary case, or the edge case, which means that we need to think about the lost character. So like I mentioned in the algorithm, we just detect if the value is over a certain character, and then we just minus it, for example. But we need to do it here. So if the letter now, the one we've added the shift factor, then the k is over 122. So remember, 122 is z. Okay, it's not only z, because we need to think about the other value. And letter, letter is out of 90. Remember 90 as well. It's for this value, 90, Latin capital letter Z. It's Latin. But of course, it shouldn't, because we are talking all, it shouldn't be, wait a second, it shouldn't now go and interlap with the capital letter. This is a small letter, now we are also checking the capital letter, and the capital letter shouldn't interlap with 97, which is the small letter E. So this one is basically the symbols in between, and which we should check, but we return it here because there might be more symbols, other symbols. So once we've done that, we have this edge case. We just need to remove. We take our letter and we remove it like this. So basically we decrement the value. And remember, I said that every if should have an else, but sometimes it won't have. It happens, it won't have. So does this work? This should be it. The Caesar cipher using Unicode, but you can also use you can use the array method, use something like that, and it will generate an array for you, and then an array of alphabet. You can also check it, but then you have a nested loop, because you will also need to, you have this loop and the one below, the split one. So in terms of performance, in terms of optimization rather, maybe it won't work. It will work, but it won't be as it will work, but it won't be as performant. And if you're going to be doing interview questions, then maybe they will definitely be asking you this question. So it seems to be good, to be working. So once the lesson here is, well, this is Hackerrank. We might get some surprise here, as I usually get. But the lesson here is that before starting to code, write down the algorithm and understand every part of it. Especially, this is, I won't say a domain. Well, a lot of the test cases are failing. Well, I don't understand why, but this is basically it works for some cases. Okay, we didn't take into consideration this value. We didn't take dot. Let me check this quickly. www 99. Wow, that's horrendous. So okay, no problem. It's the dot, maybe the dot that's not working well. Let's just go over the code. But like you see, we cover the base cases. These ones are crazy. They like the shift factor is 97, so it's a lot. In theory should work, and maybe there are some adjustment that needs to be done, but I hope you get the idea. It works for the initial versions, and later, if I have more time, I will look into more in depth into it. I'm sure that we are not just there might be some values we are not taking, because it's quite long. It's 97. It's 90. No, it's 87. So there might be some values that I need to check. Maybe it's with this, because remember, ideally you want every if to have an else. So I hope this can be an educative, if not an interesting video. Still very early in the morning, so I hope you enjoy this one, and hopefully I will have another one coming soon. Take care.